All right, let's get out our chapter 5, part 1, system of linear equations packet. So I'll give you a second to do that. All right, so let's talk about what is a system of linear equations. So basically, we're going to be talking about two equations. All right, so before we had one equation, like y equals mx plus b, and now we're going to have two of them. And basically, what we're trying to determine is the point at which they cross. Now, why is this significant? Because when you're in business, all right, you have a point called the break-even point. That's where your expenditures equal your income. So that pretty much tells you how many units you need to sell in order to start making a profit. Okay. And then another scenario is, basically, hey, which cell phone should I go with? All right, which cell phone company is going with Verizon going to be better than AT&T, right? Or is it going to be like, should I go with Verizon for TV or should I go with Xfinity for TV? Because it all depends on how much you use your phone or the TV or internet. So this is a very important unit. All right, so let's open this up. And let's just start right here. So the introduction to 5.1 is going to be just going over the basics. So a system of linear equations is a set of two or more linear equations in the same variables, meaning they both have x's and y's or a's and b's, whatever you want to call it. So there are three possible outcomes. There is one solution, no solution, or infinite solutions. So right below it, this is what it looks like on a coordinate plane. So one solution means my lines cross, all right? And my answer would be defined as the point where they cross, all right? Now, with no solution, the lines are parallel. They don't cross, all right? Notice they will never intersect. And the last one's kind of difficult to see because it's only one line, meaning it's both the same line, all right? So we have one line over top of the other line. Now, after reviewing this, we can see that our answer is going to be a point. It's going to be a coordinate point, an x and a y, okay? So a solution to a system of equations is the ordered pair that balance out both equations. So to determine whether the ordered pair 2, 5 is a solution to the set of linear equations below, what we're going to do is we see a coordinate point. So my first step is always to label. And then my second step is to substitute. All right. Well, so why did I skip over write your equation? They're already written for us. All right. So step 1 is to label. Step 2 is to write your equations, but they're already written for us. So now I'm just going to jump to substitute. So I'm going to substitute in 2 and 5 into the first one. So I have 2 plus 5, and I'm asking, I know it's easy to see, but I'm asking, is 2 plus 5 equal to 7? And the answer is yes. All right, now the one that's not as easy to see is the bottom one. So we're going to plug in 2 for x, and we're going to plug in 5 for y. And I'm asking, does that equal 7? Well, 2 times 2 is 4, minus 15. And you can see that this does not equal. Does not equal. So 2, 5 is not a solution because it didn't work out in both equations. Let's look at 3, 2. We're going to label it x, y. We don't have to write our equations because they're already written, so we're just going to substitute it in. So now we have 2 times 3 plus 3 times 2. And I'm asking, does that equal 12? Now, this might require a little bit of work. 2 times 3 is 6, plus 6. Does that equal 12? And the answer is yes. Let's look at the other equation. So now we have 2 times 3 for this one, plus 4 times 2. And I'm asking, does that equal 14? Some of you may see it, and some of you may not. So we're going to do 2 times 3, that's 6, plus 4 times 2, that's 8. And I think we can see from here that 6 plus 8 equals 14. So my answer would be 3, 2 is a solution. So in order for a point to be a solution, it has to work in both equations. If it doesn't work in one, then it's not a solution. So these are more of the Keystone practice problems. So a bakery charges X dollars per cupcake and Y dollars per icing color to use to decorate the cupcakes. Jan purchases 8 cupcakes, each decorated with 4 colors. Tony purchases 5 cupcakes, each with 6 colors. Jan spent 26 and Tony spent 18. The equations below represent the situation. How much does the bakery charge for 1 cupcake and for each color used to decorate the cupcakes? So how do I go about this? All right. Well, down here we have A, B, C, and D. A says charge for a cupcake is $2 and $1 per color. So remember up here, X was for cupcakes and Y was for icing. So that column is going to be my X values and this column is my Y values. So what I'm going to do is I'm basically going to say A, all right, is going to be 8 times 2 plus 4 times 1. And I'm asking, does that equal 26? Well, 8 times 2 is 16 plus 4. And notice this does not equal 26. So A is not my answer. B says, well, $3 per cupcake. So let's plug that in. 8 times 3. All right. Plus 4 times 50 cents. Does that equal 26? Well, 8 times 3 is 24 plus half of 4. Well, that's 2. So yeah, that does work. Now I have to check it in the other equation, the 5x plus 6y equals 18. So I'm going to do 5 times 3 plus 6 times 50 cents. I'm asking, does that equal 18? 5 times 3 is 15 plus, whoops, half of 6 is 3. So we have 15 plus 3. Does that equal 18? And the answer is yes. So my answer is B. Now you can see it does take a little bit of time to work through these problems, right? And hopefully the first equation fails in every one so that you get your answer pretty quickly, all right? It would be kind of annoying if I had to go through all of these to get to D. All right, let's look at number 2. A poster printing company charges X dollars per square foot. So I'm going to go ahead and underline that. And Y dollars per color used. Tim has 2 posters printed. The first poster has an area of 2 square feet and uses 3 colors. It costs $13. So that's the first equation, 2x plus 3y equals 13. The second poster has an area of 3 square feet and uses 5 colors. So that costs $21. That was 3x plus 5y equals 21. The equation below represents the situation. How much does the company charge per square foot? So again, first column is X, second column is Y. So we're going to do 2 times 3 plus 3 times 2. And I'm asking, does that equal 13? And the answer is no, it doesn't. 2 times 3 is 6 plus 3 times 2, that's 6. 6 plus 6 is 12, not 13. So let's go to B. Let me use a different color. So first one is 2 times 3. And the second one is 3 times 3. Okay, so we have 2 times 3 plus 3 times 3. And I'm asking, does that equal 13? And we have 2 times 3 is 6. 3 times 3 is 9. 6 plus 9 is 15. No, that didn't work either. So that's kind of nice so far. Now let's look at C. Well, the first one says $2 per square foot. So we have 2 times 2. And then it says $5 per color. So we have 3 times 5. And I think we can already see that this 2 times 2 is 4, 3 times 5 is 15, and there's no way that's going to be equal to that. So by process of elimination, my answer is D. So it says, Marcia and Greg each buy hot dogs and hamburgers for their friends at a baseball game. Marcia purchases 3 hamburgers and 4 hot dogs and spent $24. So that's the equation 3x plus 4y equals 24. And Greg spent $30 on 6 hamburgers and 2 hot dogs. So that's 6x plus 2y equals 30. It says the ordered pair 4, 3 represents the solution. What does 4, 3 mean? Well, let's look at it this way. 3 for Marcia represents hamburgers, and the 4 represents hot dogs. So notice 3 is with X, okay? And 4 is with the Y. So we know that X has something to do with hamburgers. And the 3 stands for the numbers, and my answer is in dollars. So this means $4 per hamburger and $3, okay, per hot dog. So there was no work to be done there. So Jake bought X pairs of thermal socks and Y shirts at the department store. He spent a total of $80, okay? The following equation describes the relationship between the number of pairs of thermal socks and the number of shirts purchased. 11x plus 18y equals 80. It says the ordered pair 4, 2 is the solution of the equation. What does 4, 2 represent? Well, up here it says $80, okay? And X represents the pairs and Y represents the shirts. So 4, 2 must represent that there are 4 thermal socks and 2 shirts. Now, how do I know that? Because the 11 and the 18 would be the cost, because it says right up here, X pairs. So I'm just reading the problem. So shirts cost 2 times as much as socks. It's false because shirts are 18 and socks are 11. Jake purchased 4 pairs of socks, okay, and 2 shirts. Sounds good. There we go. Francisco purchased X hot dogs and Y hamburgers at the baseball game. He spent a total of $10. The equation below describes the relationship between the number of hot dogs and hamburgers purchased. So 3x plus 4y equals 10. So the solution is 2, 1. What does 2, 1 represent? Well, it says X hot dogs and Y hamburgers. So X is hot dogs and Y is hamburgers. So hamburgers cost 2 times as much? No, because it says 3 for a hot dog and 4 for a hamburger. So we know that's not true. Francisco purchased 2 hot dogs and 1 hamburger. There you go. B. Just from reading the problem. It says it right there. X hot dogs, Y hamburgers. Now, at the theater, Fred purchased X popcorns and Y drinks. He spent a total of $26. All right, I think we've read these type enough, so we can skip down here. It says the ordered pair 5, 2 represents the solution. Okay, so X is popcorn, Y is drinks. So it says popcorn costs $5 and drinks cost $2. Okay. Well, I don't think that's it because it says Fred purchased X popcorn and Y drinks. So Fred purchased 5 popcorns and 2 drinks. All right. So real world application. All right. And this is like a build-in to what we're going to be doing next. So your family opens a bed and breakfast. They spend $600 on preparing a bedroom to rent. The cost to your family for food and utilities is $15 per night. Therefore, the cost in dollars that your family must spend is represented by the equation C equals 15x plus 600. C stands for cost, okay? So where X is the number of nights, your family charges $75 per night to rent the bedroom. Therefore, the revenue earned in dollars is represented by the equation R equals 75x, where X is the number of nights. Complete the table to determine how many nights your family needs to rent the bedroom to break even. All right, so we're going to do this a couple different ways. All right. So if you remember me talking at the beginning, okay, when I was telling you expenses and income, same type of problem. So we're trying to find the break-even point. Where do these two things overlap? So let's start out with something that's fairly easy. Let's talk about revenue. If I rent it out for 0 nights, I make $0. If I rent it out for 1 night, I make 75. 2 nights, 150. 3 nights, 225, and so on and so on. All right. So we could just keep counting by 75. So I think that's the easiest way to do it here, or you could type it into your calculator and graph it. But I think it's just easier if I type it in this way. So 7 and 525, 8 and 600, 9 and 675, 10 is 750, and 11 is 825. It was easy. Now let's talk about cost. Cost is, well, costs $15 per night in utilities plus the 600. So if I rent it out 0 nights, it still costs me $600. All right, because I'm putting in 0 for X. So I'd have 15 times 0. Well, that's plus the 600, that's 600. Now we're going to plug in 1, so we have 15 times 1, that's 15, plus 600, it's 615. Plug in 2, 15 times 2, that's 30, plus 60, there's 600, that's 630. So I think we can see we're going up by 15, so 645, 660, 675, 700, oop, not 700, sorry, 690, 705, 720. All right, we're getting closer. 735 and 750 and 765. So if we look at this, we can see that the two will break even right here. How do I know? Because my cost will equal my revenue. So if I rent this out for at least 10 nights, then I'm going to start making money. All right. So now we need to plot all of these points. Oof. All right. So we got everything in there. So let's plot the blue line. So it says 0, then 75, 150. All right, this is nice. Looks like I get to plot them at all of the corner of the boxes. There we go. So there's my line. Now let's plot the green line. Well, that's 600. Now I can't plot 615, but I can plot 5 and 675, because notice that's the next block. So 675 is at 5, so let's go 5 and 675. And then the next block would be 750. That's right here at 10. So it's right there. So let's plot those points. So as you can see, the blue line, my revenue, finally becomes greater than my cost function at 10. So that's where I get 10. Notice that is my break even point. Okay, it's at 10 nights and $750. Now, how could I get this without doing all of that? Well, we're going to go into this later on, but we know from business, my break even point is when my cost equals my revenue. So I simply have 15x plus 600 equals, and then it was 75x. So I can go through and I can actually solve this. And subtract 15x from both sides because 15 is the smaller of the two. So that gives me 600 equals 60x. And then we can divide by 60. And look at that. I get x equals 10. So that is a little bit of the intro to 5-1.